1 for the Additive Steel Manufacturing Project, and this is my team.
Hi, this is Mary.
Hi, I'm Arthur.
Hi, I'm Sean.
Hi, I'm Will, and this is our presentation of our work. So this is our design. We first started off with a bunch of different sketches. We had Mary gave her design, and this one was from Sean, and we took all the different designs together, and then I sketched out our original inspiration for the part. That was during our sketching phase. We then started doing some CAD modeling, and this is an early part that Arthur started designing. And then later I took the original design that we had and kind of made a rough outline, and then sent those files over to Arthur.
Yeah, really we designed this almost dueling banjo style. He sent me a file, I sent one back, and after maybe 9 times or so, eventually we had a part that was both, I guess, uniquely ours at the same time. Yeah.
And for my original design, it had all the features in there and was primarily focused on just meeting the requirements needed. Whenever I passed it off to Arthur, he made a nice streamlined design that you can see in our last rendition versus my meteor big handle that ended up not being super comfortable in the hand. And so over the time that we prototyped, one of the coolest parts that we did was this detachable design, where when you open the part, it can be 2 separate parts to use for different cool things at the same time.
Yeah, Jackson got the inspiration for that design from high-end kitchen shears. We also drew inspiration from outdoor utility knives and for chopping. The prototyping process for this, we had 3 main phases of prototyping. We had an FDM print, we then did a binder jet epoxy 12 print as well, and then lastly, because of course, laser powder bed prints never go right the first time. We broke it up into several segments of fail points, printed it, and got an idea for exactly what would fail our first attempt all across the board. So our next one would be successful.
Yeah, so here you can see all the different parts that go into our multi-tool, all the different functions, with the main unique one being the fact that it does detach, so you can use a hammer independently and it's meant to fit perfectly in your hand, and all the different tools have different functions, whether they're apart or together.
I'm going to pass it off to Sean for a more detailed review on the materials used.
Most multi-tools in modern day usage are used with 420 stainless steel, although with worries with the blades that we have incorporated in our multi-tool, we were worried about the toughness and the ductility of them. Therefore, we switched to using a precipitation hardened stainless steel as the main literature review component within the actual tool itself. Our industry partner was SSAB, which utilized SSAB 0, a martensitic steel, instead of the stainless steel, the precipitation hardened stainless steels that we were originally going to utilize. Because of that, we don't have a whole lot of data related to laser powder bed fusion of SSAB 0, but what we do know is the ultimate tensile strength, the elongation, the yield strength, and other properties related to it, and we have incorporated that into the FEA component of the actual multi-tool itself. And with that, I will be moving on to introducing Mary to talk about the FEA of the tool.
Based on the FEA results, here are some of the parts came out successfully and structurally safe due to having low stress and minimum elastic deformation. So the material yield strength is 1140 megapascal, and we have 5 parts came out less than that amount. So hammer, flathead, seat belt cutter, Phillips key, and prior. We're able to withstand the maximum worst case loads a human being can apply. The rest of the components showed plastic deformation and ruptured, either at the neck of the keys or in the fusing area. I'm giving the word to William to talk about the logistics of industrial partners.
Hi, I'm Will. My role is to be the main communicator with our industry partners. At first, we experienced a couple challenges reaching out and getting an actual partner to help us out with our making of the part, but fortunately, we got in contact with an individual at SSAB who actually, they do their 3D printing over in Sweden, so we'll be getting the part hand delivered by an employee there to the American Makes competition. And so we also got some prototyping done through Owens Corning, which was very helpful in getting, a real life part in our hands to see the logistics of how the part works.